Here we are at our example 5 from our 4.4 set of notes. We're asked to solve this by factoring. And in order to be able to do that, in order to solve, we have to get everything onto one side and 0 on the other. Usually you want your a term for your degree to be positive. So you want your leading coefficient to be a positive value. And so that would be this 18. We want that 18 to be positive. So we're going to keep that on the left side, which means all of this stuff over here we need to bring over to the other side. And we can accomplish that by pretty much just adding the opposite. So we're going to add 3x to both sides. And then we're also going to subtract 21 from both sides. And when we do that, we're left then with 18x squared plus 13x minus 21. Whereas on the right side, these are going to cancel all the way. And we're left with 0 on that one side. So you will at times, especially as you kind of progress in math, you're going to have to remove all the things on one side, over to one side. But again, you want that goal of keeping your highest leading coefficient, in this case that 18, to be a positive. That's like a strategy, okay? Now, we're going to look and see, can we pull out a GCF? Unfortunately, we can't. 3 is tempting, but unfortunately, 13 is not evenly divisible by 3. So, we're going to go ahead and have to create our x and look at our a value as 18 and our c value is 21. Take the product of those, and we're left with 378 when we do that. Our b value here is 13. So we're trying to find a pair that we combine to give us 13. Now, usually when you see a high a value like this, a high product of a times c like that, 378, and a b value of 13, what that starts to tell us is that our two numbers that we're going to use are kind of closer together, okay? Now, we're still going to create the list, though, of 378. But that should be in the back of our mind. When we see such a high product, but our b value is small, we're going to see that these two numbers are kind of closer together with one another. So we have 1 and 378. We have 2 and 189. Well, these two numbers are not really close together, right? That's kind of what I'm illustrating. We have 3 and 126. We have 6 and 63. Neither of these numbers really close together. We have 7 and 54. We have 9 and 42. We have 14 and 17, and now we're starting to get a little bit closer. So 14 and 27. And then lastly, 18 and 21. And then that is the extent of our list. Which pair combines to give us 13? Well, that would be our our 14 and our 27. So we're going to break down our 13x into 14x and 27x. Now, to play with the signs to get that to be a positive 13 that we need, well, we need a positive 27x and a negative 14x. We'll go ahead and drop down those values. Oops, probably should have filled that in. 18x squared and our negative 21. We'll just go ahead and drop those down. Now we can go ahead and factor by grouping. So looking at the first pair, we notice that we can pull out a 2x out of those. And when we do that, we're left with a 9x minus 7. When we look at the second pair, we notice that we can pull out a 3, positive 3. And when we do that, we're left with 9x minus 7 equals 0. Now, since they both share that common factor of the 9x minus 7, we can pull that out of both of those. And then we're left also with our 2x plus 3 when we do that. Equals 0. Zero product property says we can go ahead and split these up and set each one equal to 0. So we'll go ahead and do that. And now all we're doing is just solving each one separately. So we'll go ahead and add 7 to both sides. This first one, so we end up with 9x equals 7. And then divide both sides by that coefficient 9. So x comes out to be 7/9. For our other one, we'll go ahead and subtract 3 from both sides. End up with 2x equals -3. And then divide that coefficient of 2. So we get x equals -3/2. So these are our two solutions. So again, though, we have to first get everything over to one side, make it equal to 0 on the other. We would look for a GCF if we can. Unfortunately, we didn't get that in this one. And then we factor it down like we've been doing. And then zero product property kicked in, where we set each one equal to 0 and solved each one separately. Again, though, that is example 5 from our 4.4 set of notes.